Now let's treat some questions under the topic equation of motion. But before we go into that, I'd like us to talk about the techniques or tools or patterns. We use graph, or we use the equations already derived. When we talk about the graph, we have the graph of acceleration. But in this instance, we are talking about constant acceleration, motion with constant acceleration. When the acceleration is 0, this is A. Acceleration is 0, no acceleration. The velocity time graph will be like this, straight. V time A. See, this one is in second. This one is meter per second square. This one is meters per second. This one is in second. So the distance time graph, S in meters, will look like this, straight. You can see it will be straight. But most times we have it with acceleration. We have it with acceleration. And at that time, our acceleration will have value. In this instance, please, because we still consider the ones where the acceleration vary. The acceleration is like this, straight. The acceleration is like this, straight. That is constant acceleration. And the velocity will be like this now. And the distance time graph will be like this. Depending. You can see. So most times when we want to solve using graph, we use the velocity time graph. We use the velocity time graph. Why? From velocity time graph, you can find the acceleration and you can find the distance with ease. From acceleration, you cannot find the distance with ease. But being that velocity time graph is intermediate between the two of them, you can find velocity, you can find the distance or displacement, and you can find the acceleration. So you can see when the acceleration is nil, the velocity in this place A equals to 0. In this place, A has value. So this one too, it can also come down. You can also have it like this. You can also, in any pattern, you can have it. So with this, we can solve our problems. Then we can also use our equations. We can also use our derived equations. You remember the equations? V equals U plus h, where U is initial velocity. A is acceleration. C is time. V is final velocity. We also have another equation. V squared equals U squared plus 2AS. We have brought in another entity here now. So S is the distance or displacement. So in physics, when we talk about distance, we are referring to displacement mainly. We also have this equation, S equals ut plus half at squared. We can also, that's how we derive this equation. But you can make it like this: v squared minus u squared equals 2as. In essence, you can say v minus u into v plus u equals 2as. You can say you want to get s, bring this one under. You want to get a, bring 2s under. What I mean is this: you can say v into v plus u over 2a equals to s. You can also say v to v plus u over 2s equals to a. So you can see, with all this, you can solve any equation, any question of motion that involves constant acceleration. Let's go to testing with some questions. A car moving with a velocity of 10 meters per second accelerates uniformly at 1 meters per second squared until it reaches a velocity of 50 meters per second. Calculate 1, the time taken; 2, the distance traveled during the acceleration; 3, the velocity reached 100 meters from the place where the acceleration began. So in the question, we are given these conditions. U, initial velocity 10 meters per second. A, 1 meter per second squared. V, 50 meters per second. We are asked to find T, the time for the traveling. S, the distance covered during the acceleration. And we also ask, what will be the velocity when S equals to 100 meters? Let's start using equation of motion. This is how it will look like. The time, we know that V equals U plus 80. So T will be equal to V minus U over A. And we know, just by change of subject of formula, V is 15, A is 10, and V is 10, A is 1. So it's equal to 5 seconds. That is our T. It now also asks us, what is S? We can use S equals UT plus half AT squared, but I'd rather we use this one. V squared equals U squared minus plus 2as. V squared equals V squared plus 2as. So we have V to be 15 squared minus 10 squared all over 2 into A to give us S. And that is 15 plus 10 into 15 minus 10 over 2. So what does that give us? 25 times 5 over 2 is 62.5 meters. Straight away. It also asks us, what is the velocity when S equals 100? So what does that give us? V squared is equal to 10 squared plus 2 into 1 into 100, which gives us 100 plus 200, 300. So V is equal to square root of 300, which is 17.32 meters per second. That is our velocity. Now, if we want to use velocity time graph, we draw it like this. Our U is 10, our V is 15, so we draw. And we know what our A is. Our A is 1 meter per second. We have known from straight line equation, the gradient is 1, that is, this is T. 15, the horizontal, the vertical change, that is delta Y over delta H, delta X. In this instance, we have it as delta V over delta T is equal to A. So, what is our delta V? 15 minus 10. What is our A? Is 1 is equal to delta T, which is equal to 5 7. So, T here is 5. We are also asked, what will be the distance? We have found this place as 5. We have found this place as 15. So, S is equal to half into 15 plus 10 times 5. That is the area of this trapezium. The area of this trapezium. And that's, on solving this, it will give you 62.5 meters. We were also asked, what will be the velocity when S equals to 100? So we are asked, what will be the V if the total area here is 100? That's what they are asking us. We know that this is going to be, this place will be V minus 10 over 1. That is the acceleration. It's going to be the T at this point. So this place is equal to 10 T minus 10. And what will be the area now? The area is going to be half of V plus 10 into, T is V minus 10. Please, T is V minus 10. So the area now will be half into V plus 10, since A is 1, into V minus 10 is equal to 100. So what does that give? What does that mean? It means that V squared minus 100 is equal to 200. So V is equal to root of 300. Just as we got here, our V is at 17.32 meters per second. So very easy and straightforward. Now we have another question. A train starts from station P and accelerates uniformly for 2 minutes, that is 120 seconds, reaching a speed of 48 kilometers per hour. It continues at this speed for 5 minutes, that is 300 seconds, and then is retarded uniformly for a further 3 minutes to come to rest at station Q. Find 1. The distance PQ in kilometers, the average speed of the train. 3. The acceleration in meters per second squared. 4. The time taken to cover half the distance between P and Q. Now, from the question, it starts from rest, from P, and accelerates for 2 minutes. And so that's what we have here. That's 120 seconds. We were told that it accelerated until it got to 48 kilometers per hour. It then continues at this speed for 5 minutes, and that is additional 300 seconds. So we have 420 here. And retarded uniformly for a further 3 minutes to come to rest at station Q here. So let's see. So 3 minutes is 180, plus this one we have 600 here. So this place is V1. We are now asked that we should calculate the distance PQ. Distance PQ. The average speed of the train. Acceleration and the time taken to cover half the distance. Time for half distance. So now we have V1 here. Let's see what V1 is. Our V1 is 48 kilometers per hour. And we have known how to convert to meters per second. So it is going to be 48 times 10 over 36. 12 over 4, 12 over 3. It's 40 over 3 meters per second. So here, you can say it is 40 over 3 meters per second. From this, the distance PQ. Distance PQ is equal to area of the trapezium. And what's the area? We know this place to this place is 600. This place to this place is 300. So, and the vertical height is 40 over 3. So what that's going to give us? Half 600 plus 300 into 40 over 3 is 940 over 2 times 3. So here, this one gives me 300. Here, this one gives me 20. So that is 6,000 meters, which equals 6 kilometers. That is 6 kilometers. We are asked, what is the average speed? The average speed is equal to total distance over total time. And that is equal to, what is total distance? 6,000 meters. What is the total time? 600. And that gives us 10 meters per second. Now we need to convert it to kilometers per hour. And that will be equal to 10 times 36 over 10. It's 36 kilometers per hour. We also asked, what is the time, the acceleration? A. What is the acceleration? We can see that the acceleration took place here, retardation took place here. So A is change in velocity over change in time. And that is 40 over 3 minus 0 divided by 120 minus 0, which is 40 over 3 times 1 over 120. So 3. So we have 1 over 9 meters per second squared. We also asked, what is the time for half of the distance? If you look at it, if you calculate the distance here, to confirm if it is up to half of the distance or more than half, it's always safe to check. So let's see, what is the distance from here to here? This place alone. During acceleration, distance is equal to half into 120 times 40 over 3. So what do I have here? 20. That is 800 meters. So which means that it's not up to half of the distance. So we need, if I want to continue with this format, I will just try to carve out 2,200 meters from this place. And what will that be? Let's make this one C. So 2,200, because this will be, everything here should be 3,000. So it will be 3,000 minus 800 of this. So this place that I'm trying to calculate now will be 2,200. That's just one way of doing it. And it's going to be 40 over 3 into T minus 120. And that gives me 2200 times 3 over 40 equals to T minus 120. So this one gives this. This place is 5, 4. So T is equal to 120 plus 2, 162, which is 282 seconds. So that happens after 282 seconds. Another way you can look at it straight, once you are confirmed that during the acceleration, it's not to this, you just cut this out and find the area of this trapezium. That is 3,000 is equal to T, this place, plus T minus 120, that is this place to this place. T minus 120. What is the perpendicular height? 40 over 3, all half. So what do you have here? It's going to be 2t minus 120 into 40 over 6. So we are going to have 3000 times 6 over 40 plus 120 is equal to 2t. So just to find the t straight. So what do we have here? We have this. 2 here. 2 here. So we have 450 plus 120 is equal to 2t. So this one is 225 plus 60 is equal to t, which is 2857. So you can see it's fun once you know what you are doing. Thank you very much. Let's go to the next question. Car A is traveling at a steady speed of 60 km per hour and passes a stationary car B. The driver of car B immediately accelerates, reaching 80 km per hour in 20 seconds, and continues at this speed until he overtakes car A. Find the distance traveled by car B when this happens. So from the question, we realize that the bus moved past the car with 15 meters per second, accelerated for 0.2 meters per second squared for 5 seconds. So let's see the final velocity. V for the car, for the bus, is equal to 15 plus 0.2 times 5, which is equal to 16. So this place is 16 meters per second. Let's see, for the car, we want to find the time it got to final velocity. So car, the final velocity is 30. Initial velocity is 0 plus 0.5 into t1 minus 30 because it started its own motion after 30 seconds. So we now have t1 minus 30 is equal to 30 over 0.5, which is equal to 60. So t1 is equal to 60 plus 30 is equal to 90. So this place is 90. We were asked what will be the distance between the car and the bus after time, that is after 30 seconds. 30 seconds after the car has gotten to its final velocity, and this one will be t1 plus 30, which equals to 120. So we are asked what will be the distance between them at time 120. Let's calculate the distance moved by the bus and the distance moved by the car at time 120. Distance moved by bus is equal to this distance here, that is half of 15 and 16 times 5 plus the other one. Let's do that. 15 plus 16 over 2 times 5 plus 120 minus 5 times 16, and that is 31 times 5 over 2 plus 115 times 16. That is distance moved by the bus. So that gives me 1917.5 meters. Now, let's calculate the distance moved by the car. Distance moved by the car. By car at t equals 120. So it's going to be, what is the vertical distance? 30. And the sum of the half of this. So we are having half into 120 minus 30 plus 120 minus 90 times 30, and that is going to give me, this is 120 minus, that is half, because this is 240 minus 120 times 120 times 30, that is 1,800 meters. So distance between bus and car at t equals 120 is equal to 1917.5 minus 1800, which equals to 117.5 meters. It's equal to 117.5 meters. Now, we are also asked, at what time will the car overtake the bus? We can easily calculate using concept of relative velocity, since the velocities of the car and the bus are constant. But let's continue with this technique. That will happen at time t1, at time t2. Yes, let me put it. At time t2. So, which means that at time t2, distance moved by car will be equal to distance covered by the bus. So, let's check. The distance by the car will be equal to t2 minus 30 plus t2 minus 90 times 30. So, t2 minus 30 plus t2 minus 90 times 30, which is equal to 30 into, yes, sorry, it's going to be half. So the distance covered by the car, is equal to half t2 minus 30 plus t2 minus 90 times 30. At the end of the day, it's going to give me 30 into t2 minus 60. That is the distance covered by the car. Now let's see the distance covered by the bus. S-bus will be equal to this distance during acceleration, that is half into 16 plus 15 times 5 plus t2 minus 5, because the constant motion starts after 5 seconds, times 16, and that gives me 77.5 plus 16 t2 minus 80, which is 16 t2 minus 2.5. And from our understanding, when the overtaking takes place, S car will be equal to S bus. Therefore, 16 t2 minus 2.5 will be equal to 30 t2 minus 1,800. So what does that give me? It says 1800 minus 2.5 will be equal to 30 t2 minus 16 t2, which is equal to 14 t2. So t2, that is the time at which overtaking takes place, will be equal to 1797.2 over 14. Let's see. Which is 128.39, approximately 128.40 seconds. So the overtaking will take place at 128.40 seconds. A body is moving in a straight line with constant acceleration. 1 second after passing a point A, it is 10 meters from A. In the next second, it travels a further 40 meters. Find 1, the velocity on passing A. 2, the acceleration. 3, the velocity after traveling 100 meters from A. 4, the time taken to cover this distance. Now, from the question, we get some, we understand some things, that acceleration is constant. U is not given. But we were told that after 1 second, the distance covered is 10. After 2 seconds, the distance covered will be 10 plus 14, which is 24. We are now asked, what is the velocity when the distance traveled is 100 meters? And we are also asked the initial velocity, the acceleration, at the time at which that occurred. From here, let's see what we can get. We can use the equations of motion, or we can still go through using this. So let's use the equation of motion. That is S equals ut plus half a t squared. When t is 1 second, S is 10. So we have 10 equals to u plus half a, that is a over 2. So 20 will be equal to 2u plus a. From this also, we can also use this graph to attest to this fact. When t equals to 2, s is 24, which is 2u plus half a times 2 squared. So we have 24 equals 2u plus 2a. So we have these two to worry about. So this is equation 2. Let's subtract equation 1 from 2. So we have 4 will equal to a. So our acceleration is 4 meters per second. A equals 4 meters per second squared. Yeah, 4 meters per second squared. Our A is 4 meters per second squared. So from this, we can find our U. So 10 equals to U plus 4 over 2. That is substituting A in this place. Therefore, U will be equal to 10 minus 2, which is equal to 8 meters per second. That's our U. Now it also asks us, what is the velocity when s equals to 100? What is the velocity when s equals to 100? So we can say that v minus u into v. Okay, let me make it straight like this. V squared equals u squared plus 2ax. So v squared will be equal to 8 squared plus 2 times 4 times 100. This is 64 plus 800. So v at this time will be equal to 29.3, let's say approximately 29.4 meters per second. And to find the time at which that will occur, we can use v equals u plus 8. And what is our u? We find it to be 8. 29.4 equals to 8. What is our A? 4. So T will be equal to 29.4 minus 8 over 4, which will be 21.4 over 4. That is 5.35 seconds after. That's 5.35 seconds after. A, B, and C are 3 points on a straight road. A car passes A with a speed of 5 meters per second and travels from A to B with a constant acceleration of 2 meters per second squared. From B to C, the car has a constant retardation of 3.5 meters per second squared and comes to rest at C. If the total distance from A to C is 475 meters, find A, the speed of the car at B, B, the distance of B from A. Let's use velocity time graph. Now we are told that the body was initially with 5 meters per second. It accelerated and then decelerated with 3.5 meters per second squared and accelerated with 2 meters per second squared. The total distance covered is 475 meters. So let's see that this one is T1 here and this one is T2 here. S1, the distance here, will be equal to the time. T1 will be equal to V minus 5 over 2. That is T1. And T2 will be equal to V. Okay, let me make it like this. T2 minus T1. T2 minus T1 will be equal to V over 3.5. Will be equal to V over 3.5. And we know that, let's say S1 will be equal to V squared minus 5 squared over 2 times 2 over 2a. S2 will be equal to V squared over 2 times 3.5, because this one is 0. The velocity here is 0. Now, S1 plus S2 is equal to 475. And T1 is this. T2. Now let's see. So I have V squared minus 5 squared over 4 plus V squared over 7 is equal to 475. Now, so I have 7V squared minus 25 times 7, 175 plus 4V squared is equal to 28 times 475. So I have 11V squared is equal to 13,300 plus 175. So V squared is equal to 13475 over 11, and that gives me 1225. So V is equal to square root of 1225, which is equal to 35 meters per second. So the velocity at B is 35 meters per second. We were also asked to find the distance from A to B. from A to B. So what does that give me? I have V here, I have here. So S1 is equal to half of this place, 5 plus 35 times, okay, I did not get T1. Let me use so what is T1? So 35 is equal to 5 plus 81. And A is 2. So which is 5 plus 2 T1. So 30 equals 2 T1. T1 is equal to 15 seconds. So this place is 15. So S1 will be equal to half 5 plus 35 times 15, which is 20 times 15 is equal to 300 meters. So distance from A to B is 300 meters. The velocity at B is 35 meters per second. The maximum possible acceleration of a train is 1.5 meters per second squared. Its maximum speed is 30 meters per second, and its maximum retardation is 4.5 meters per second squared. What is the shortest time from rest to rest in which it can cover 300 meters? A, that is 300 meters. B, 1000 meters. Hint, use a velocity time graph. So we are told that the train it has acceleration of 1.5 meters per second squared max, and retardation of 4.5 meters per second squared. I will now ask the minimum time to travel 300 meters. I was told that the Vmax is 30 meters per second. Now let's see, assuming it travels from rest to 30 meters per second and decelerated, what will be the total distance traveled? If it is going to be more than 300 meters or less than 300 meters, and from there we know how to tackle it. So let's see. We have this one 1.5. This one is 4.5, and this one is 30. Those are the maximum conditions. So if it moves from rest to 30, how many seconds will that be? So T1, T2. So if it moves from here to here now, it's going to be 30 over T1 minus 0 is equal to 1.5. So T1 is equal to 30 over 1.5, which is equal to 20 seconds. So T1 here is equal to 20 seconds. Let's see how long it will take for this place too. From 30 to 0. Let's see. It's going to be 30 minus 0 over T1 minus T2 is equal to minus 3.5. And what is our T1? That's 20. So 30 over minus 4.5, sorry. Minus 4.5 is equal to T1 minus is equal to 20 minus T2. So T2 is equal to 20 plus 30 over 4.5, which is 20 plus 20 over 3. And that's going to be 80 over 3 seconds. That is T2. 80 over 3 seconds. I don't want to approximate. Now, if we look at this, what will be the total distance traveled if all these maximum conditions are fulfilled, like this? So, distance will be equal to half times 80 over 3 times 30. So, which is 400 meters. What does that tell us? That if the train should move from 0 to 30 using this acceleration and decelerate at the same time, it will exceed this. Now, we are going to walk with a velocity that is lesser than 30 meters per second. It will have to move to that velocity, which is less than 30 meters per second, decelerate to cover the 300 meters per second, to cover the distance of 300 meters. So let us calculate the minimum time to do that. So now the new maximum velocity is going to be v. We have T1, T2, and the total distance traveled will be 300. Now let's see. 300 is equal to half v into T2. That is the equation to cover this area. Now, during acceleration, it will accelerate for T1. So V is equal to 0 plus 1.5 T1. So V is 1.5 T1. That is our velocity. And what is T2? T2 minus T1 will be equal to V over 4.5 from this. So, what does that give us? It means that T2, 4.5 T2 minus 4.5 T1 is equal to V. If you look at this, it means that if, okay, this is 3. So 4.5 T2 minus 4.5 T1 is equal to 1.5 T1. What does that say? It means that T1 is, let's see, okay, so it means that 3T2 minus T1 is equal to T1. 3T2 minus T1 is equal to T1. What does that say? It means that this place is 1/3 of this place, and with this we can cover everything. So T1 is equal to 3 into T2 minus T1. So you can see that 4T1 is equal to 3T2, and T1 is 3 over 4T2. Now we are going to use this in this place. Now our V will be equal to 1.5 T1, and let's see, T2 is equal to 4 over 3 T1. So V is equal to 1.5 times, so this is 1.5 times 3 over 4 T2. When you substitute this in this place, so we have, therefore, 300 is equal to half V T2, which is equal to half times, we bring this one inside this place, 1.5 times 3 over 4 T2 times T2. So 300 will be equal to 4.5 over 8 T2 squared. And so we will have T2 squared will be equal to 300 times 8 over 4.5. So T2 will be equal to, so the time to cover 300 meters is 23.1 seconds. Now, we have realized that if it moved fully at the highest acceleration and deceleration to the highest velocity, the total distance covered is 400 meters. Now we are asked to find the time to cover, the shortest time to cover 1000 meters. Let's go and do that. Now, since if it moved up and then decelerated, the total distance is 400. Then it means that when it gets to highest velocity, that is 30, it means that it has to travel with that 30 for some time and then decelerate. So we have calculated, this one is 1.5, that T1 is 20. Now we have discovered that T1 is 20. From T2 to this place is 20 over 3. So this place is T2 plus 20 over 3. Here now, this place and this place is 400. This place is 600. So let's calculate what T2 is. So T2 minus T1 will be equal to 600 over 30 because it moved with constant velocity. But you know that T1 is 20, so T2 minus 20 is equal to 20. T2 will be equal to 40. And the final one here, which is T3. So T3, the total time to travel, the total time to cover the distance, total time to cover 1000 meters will be equal to 40 plus 20 over 3, which is 40 plus 6.67, which is approximately 46.7 seconds. So it covered 1000 meters in 46.7 seconds. A train moves up from station A with constant acceleration 1 meters per second squared and attains a stop speed of v meters per second, which it maintains for 9.6 kilometers until it reaches station B, 10.05 kilometers from A. The brakes are then applied, causing a constant retardation, a meters per second squared, and as soon as the train comes to rest, it is reversed to station B First, with constant acceleration 1 meter per second squared, and then a constant retardation of 5 meters per second squared. If it comes to rest at B 422 seconds after it left A, find V and A and the distance the train overshot B before reversing. Hint: use a velocity time graph. So we have this information. The acceleration is 1 meter per second squared, and then it traveled with V. It accelerated to V and traveled to B with V. The total distance from B to A is 10.05 kilometers. Distance traveled with constant velocity, that is, the distance in this place is 9.6. So distance traveled during acceleration will be equal to 10.05 minus 9.6, which is 0.45 kilometers, which is 450 meters. Then, what does that tell us? We can calculate V straight from this, since we know the acceleration. S equals to U. We know S, so we can say 450 is equal to half V half V squared minus U squared over A. And we know our U to be 0. It's got started from rest. So we can say that, and our A is 1. So it's equal to V squared minus 0 over 2 into 1. V squared over 2. So V squared is equal to 2 times 450, which is 900. So V is equal to 30 meters per second. So our V is 30 meters per second. We have been able to achieve that. Let's look at another part of the question. Now, we can now see, once it got to B, it now tried to come to rest. But it has already overshot B. Once it got here, it initially reversed back with 1 meter per second squared, and then come to rest at using 5 meters per second squared. So the total time here is 422. 422. From here to that place is 422. Now let's look at what the whole graph is saying. We have already gotten this place to be 30. So it means that this place now, we can find it. How? We can say that 30 equals to U 0 plus 1 into T1. So T1 is equal to 30. So we got this. We can also get this place, T2. So T2 minus T1 will be equal to 9.6 times 1000 over 30, which is equal to 9600 over 30. So 320. And we know our T1 to be 30. So T2 will be equal to 320 plus T1, which is equal to 320 plus 30, which is equal to 350. So our T2 is 350. Now, we can either look at it from this perspective, that from this place to this place will be 422 minus 350, or we can work it out using our normal orientation axis as it is presented to us. Let's look at it as a whole first. From this place to this place, I call it. Now, let's call this place T4. So, V 0 minus V, okay, let me do it like that. 0 minus V2 over minus 1 will be equal to T4 minus T3. So V2 is equal to T4 minus T3. Now, we also know that this V2, the final one is 0, yes. 0 minus V2 over 5 will be equal to 422 minus T4. 422 minus T4. So, V2 is equal to 422 minus T4. So let me call this one. Okay, we have it like this because we are going to generate several equations. So V2 is 422 minus T4 times 5. Now I want to see, and at the same time, we can see that T4 minus T3 is equal to 5 into 422 minus T4. I want to eliminate T4. I want to find the distance from here to here to solve the problem. Now, so from this expression now, I can say that T4 minus T3 is equal to 5 into 422 minus T4. So 422 minus T4 is T4 minus T3 over 5. On adding the two, 422 minus T4 plus T4 minus T3 is going to give me 422 minus T4 plus 5 into 422 minus T4. And that will give me 6 into 422 minus T4. You will see. So I'm going to have 422 minus T3 is equal to 6 into 422 minus T4. And what does that say? It's also equal to 6 over 5 into T4 minus T3. Because if this one, 422 minus T4 is this one over 5. So it's going to be 6 over 5 T4 minus T3. Now let's see what we are going to do. So we have established that V2 will be equal to T4 minus T3. We have established that. And we have now seen that T4 minus T3 is equal to 5 over 6 into 422 minus T3. It's something you could have gotten straight, but to be clear to everybody, that's why I got it through this way. Because of the ratio. This one will be 5 and this is ratio 1. So the 2 will be 6. Now, V, our V2, we have established that it's going to be 5 over 6, 422 minus T3. We have gotten that. So S, let's call this one S1, S2, the total here. So S2 will be equal to half V2 into 422 minus T3, which is going to be half times 5 over 6 into 422 minus T3. That is S2. Our S1 at the same time S1 is equal to half into 30 into T3 minus 350. So we don't need to bring in A in this instance. So it has made our work so easy. We have T3 here, we have T3 here. So we have 15. So, and from the question, they have told us that it overshot before it started reversing. That is S1 is equal to S2. That is the condition now. It overshot B and then it started reversing. Accelerated, decelerated, and then stopped at B. So S1 equals to S2. So we have it that 15 into T3 minus 350 will be equal to 5 over 12 into 422 minus T3 squared. Please, this one should be squared. This is V and this one is squared. Please, that one is squared there. Now, I'm going to have this one is 180 into T3 minus 350. 180 over 5, yes, is equal to 422 minus T3 all squared. So you can see S1 equals to S2. This is S2. I brought it here. S1, 15. So on analysis, it gave me this. C3 squared minus 880 T3 plus 19684 equals to 0. And from there, I apply quadratic formula. So the answer is 494 seconds or 386 seconds. And the one that can work with our equation is 386 seconds because the final packing of the train is at 422 seconds, which cannot get to 494 seconds. So our time T3 is 386 seconds. That is this place. Now, for us to find the acceleration, the deceleration rather, we are going to find it here. So A will be equal to 0 minus 30, because that's the final velocity, over 386 minus 350, which is equal to minus 30 over 36, which is equal to minus 5 over 6 meters per second squared. That is the A. Or if you can say the retardation, the deceleration. So A will be equal to minus 5 over 6 meters per second squared. Or if we say the deceleration will be equal to 5 over 6 meters per second squared. Another easier method that makes it look so simple is to just consider the motion from this place to this place. Let's see how that one looks at. So to make it easier for yourself, you just consider the motion from this place to this place. So you call this place T1 and this place T2. And this place, the time axis will be 422 minus 350. and that is 72. So from here you start working everything out, and you see how easier it will be. Now, what is our let's call this place V2. So V will be equal to, and this place is 1 and this place is 5. So V2 will be equal to T2 minus T1, because U is 0. And at the same time, V2 will be equal to 72 minus T2 into 5. And from here, you can find S1, S2. So, from knowledge of our acceleration and deceleration, since they are from the same place, we know that this place will be 1/5 of this place. This place will be 1/5 of this place. That is T2 minus T1 will be equal to 5 into 72 minus T2. So you can see we arrive at the same thing. So we know that since it is like that, we are going to divide this one in the ratio of 5 to 1. That is what this means. It means that 72 minus T1 will be equal to 6 over 5 into T2 minus T1. That's what it means. Yes, that's what it means. Or 6 of 72 minus T2. That's what it means. Because now, since this place is 1 over 5 of this total place will be 6 over 5. It will be 6 over 5 of this. Then, since we have gotten this, our velocity is this. Let's see. So our velocity V is now equal to 5 over 6 into 72 minus T1. Straightforward. And what is our distance now? Since we have gotten this for our velocity, we can now work out our distance. S1 is equal to S2. S1 is equal to S2. So this one is advantageous in that it makes what you are looking at to be smaller and simpler. So what is our distance now? S1 is 30. 30 times T1 over 2. That is S1. S2 is equal to half into V, that is 5 over 6, 72 minus T1, times time again, that is 72 minus T1. So you can see, it is so simple and straightforward. So we have 15 T1 is equal to 5 over 12 into 72 minus T1 all squared. So that was it gives. And from here, you can see 36, well this is 36 T1 is equal to 72 squared plus T1 squared minus 144 T1. So what does that give us? T1 squared minus 180 T1 plus 72 squared equals to 0. So from there, you can find your T1. And when you get your T1, you can get the acceleration. So you can see, the only one compatible with our equation now will be 36 seconds. Because we have 36 seconds or 144 seconds. So from this, you can calculate our A. Our A will now be equal to 0 minus 30 over 36 minus 0, which is equal to minus 5 over 6. Straightforward. So it depends. You can make it easier for yourself. This one looks cleaner, tidier, and easier. A train starts from rest and for the first kilometer moves with constant acceleration. For the next 3 kilometers, it has constant velocity. And for another 2 kilometers, it moves with constant retardation. To come to rest after 10 minutes, draw the velocity time graph and find the maximum speed and the 3 time intervals. You are told that the motion is like this. Everything took 10 minutes, which is 600 seconds. It initially accelerated 1 kilometer. Move with constant velocity 3 kilometers. And then here 2 kilometers comes to rest. And this is our V. We are taught to find the V and the time intervals. Let's see. Here, we have this one as T1, T2, and we have that. For the first kilometer, for the first part, we have 1,000 meters is equal to half into V T1. For the next one, that is 3,000, is equal to V into T2 minus T1. And for the last part, that's 2,000, is equal to half V into 600 minus T2. We now have overall distance, that is 6,000, is equal to, that is 1 plus 2, 3,000 plus 2,000 is 6,000, is equal to this one, that is half 600 plus T2 minus T1 into V. You can see this is 600, this is T2 minus T1. So I'm going to have 12,000 is equal to 600V plus T2 minus T1 V. And if you look at this, we have this here. This T2 minus T1 into V is equal to 3,000. And so I have 12,000 is equal to 600V plus 3,000. So 9,000 over 600 is equal to V. So V is equal to 15 meters per second. V is equal to 15 meters per second. Now we are to find the time interval, that is T1, T2 minus T1, and 600 minus T2. Let's get it. So from here, T1 is equal to 2000 over V, which is 2000 over 15, and that will be 4000 over 30. That's 400 over 3. T2 minus T1. So that is the first interval. 400 over 3 seconds will be equal to 3000 over 15, which will give me 200 seconds. The last part, which is 600 minus T2, 600 minus T2 will be equal to 4000 over 15, which is equal to 800 over 3 seconds. So the time interval, the first interval will be 400 over 3 seconds, the next one will be 200 seconds, and the last one will be 800 over 3 seconds. And the velocity is 15 meters per second. A particle is moving in the x direction with constant acceleration 5 meters per second squared. At time t equals 0, it passes through a certain point with velocity 20 meters per second. What is its displacement in the subsequent 5 seconds? At the instant t equals to 5 seconds, the acceleration changes to minus 10 meters per second squared. This acceleration remains constant until the particle again passes through its initial position. At what value of t does this occur? What is the extreme position of the particles in the x direction? And at what value of t does the particle reach this position? What is the velocity of the particle as it passes through its initial position? In the question, we were made to realize that the particle passed through a point with 20 meters per second, accelerated for 5 seconds with 5 meters per second squared, and then decelerated with 10 meters per second squared, and continued until it passed through the original position. We were asked to find s1, the distance after 5 seconds, that is for the period of the acceleration. We were also asked to find the extreme position, that is the position where the velocity gets to 0. And we also asked to find the time at which it got back to its initial position and the velocity at that point. Let us start. We have this as 5 meters per second. It's accelerated. Now let's find this point, this V1. So V1, and we have been given that this place is 5 seconds, is equal to 20 plus 5 times 5, which is 45 meters per second. So this maximum velocity is 45 meters per second. 45 meters per second. And from there, we can find our distance covered during the acceleration. So s1 will be equal to half into 45 plus 20 into 5, which is 65 times 5 over 2. That is 325 over 2. This is 162.5 meters. That is the distance covered in the first 5 seconds during the acceleration. We are asked the extreme position, this point, the extreme position, that is the farthest distance gotten to by the particle. Now let's see, we have this as 45 and we have this as minus 10, and this place is T1. Let's find T1 so that we can find the distance S2, and then we find the extreme position. How do we get that? We know that A will be equal to final velocity minus initial velocity over change in time, or I can say change in velocity over change in time. Minus 10 will be equal to, what is change in velocity? 0 minus 45. What is change in time? T1 minus 5. And what does that give me? T1 minus 5 is equal to minus 45 over minus 10, which is 4.5. So T1 equals to 5 plus 4.5. That is 9.5 seconds. But from here, we already know that it got to this place after 4.5 seconds. We can easily work with that now. So the area of this place now is S2. Let's find S2. S2 will be equal to half 45 into 9.5 minus 5 from this place. So we could have gotten that straight. So we have half into 45 times 4.5. And what is S2? 45 times 4.5 divided by 2. So S2 is 101.25 meters. So extreme position is equal to 101.25 plus 162.5, and that is 263.75 meters. So it is telling us that the position at this place is 263.75 meters. We were also asked that it traveled back. What will be the velocity at the point and the time it got there? So what it's saying is that this place now, the distance and the distance covered here should be equal to S1 plus S2. That is what it is saying now. So let's see. We have T2 minus 9.5 as our time now. And our A is equal to minus 10. Let's see. What is our V? Our V, because it moved from 0, we consider it from 0 to this place. We could have considered it from here to here. But from here to here, since it's on the same straight line, it's still workable. So V2 should be equal to minus 10T. Minus 10T. So S3 is half VT, which is now equal to half into minus 10T into T. That is it. So, and that is 263.75. So 263.75 equals to half into 10T squared, because it is distance. The sense is the same. We take it as the same. So I have 2 times 263.75 over 10 equals to T squared. So T will be equal to 2 times 263.75 divided by 10. So T2, T will be equal to 7.263 seconds. So what does that mean? It means that T2, that is the time at which it gets back to its initial position. T2, time it gets back to initial position will be equal to is T2, and which is equal to 9.5 plus 7.263, which equals to 16.763 seconds, approximately 16.73 seconds. Now let's check what the final velocity will be. The final velocity now, v2. Since we are taking it, we can consider from here, but let's take it from 0 and this place. So we have our a to be minus 10, v2 is equal to 0 plus a t. And what is our a? Minus 10. What is our t? Our t is 7.263. We calculated it the other time. That is T2 minus T1 minus 10 times 7.263, which is minus 72.63 meters per second. That is how to get that. So the initial distance, we got this one, so that we got the extreme position. After that, we got T2 here, and then we got the velocity. You could have also gotten it if you use equation of motion. For the first part, you know that this one is 5 seconds. S equals ut plus half at squared. So which is 20 times 5 plus half times 5 times 5 squared. And that is 100 plus 125 over 2. So what does that give me? 162.5 meters. For the extreme position, I get this in the same way by getting this final velocity v1 is equal to u plus 80, which is 20 plus 5 into 5, 45 meters per second. So the velocity will be, the final velocity here is 0. So I have 0 equals 45 because minus 10 into t. That is this one. As we got it before, we realize that t equals to 4.5 seconds. So t1 is equal to 5 plus 4.5, which is 9.5 seconds. Now we can get this again by using our equation of motion to get this final one, even straight from here. The distance from here to here is 162.5. So you can say, now we have seen that the distance up to this point is 162.5. So we can say S is equal to 162.5 plus 45t, because the acceleration is minus 10. minus half into 10 t squared. Please, this one represents change in distance. That is change in distance. So s is s1 plus delta s. That is what it means. That's equation, that's what it means. Now, we are told to find the time at which it gets back to its initial position. So initial position will be 0 now. So 0 will be equal to 162.5 plus 45t minus 5t squared. Minus 5t squared. And if I should break it further, I can still say 0 will be equal to 325 plus 90t minus 10t squared. Okay, I like it in that form. Therefore, 10t minus 10t squared minus 90t minus 325 equals to 0. So to 90 plus or minus root 90 squared plus 4 times 10 times 325 over 20, because this one is negative here, so it has made this one to be plus. So t will be equal to, so t is now 11.763563 seconds, and now that time is t2, and t2 is equal to 5 plus t. T is equal to 5 plus 11.763, which should be 16.763 seconds. That is the time. That's the time at which it gets back to its initial position. And now if you are asked to find the velocity at this point, since the motion is from this place to this place, the time we consider now is 11.763. So v at this point is going to be 45. This is our initial velocity. Minus 10 times 11.763. That is minus 72.63 meters per second. So sometimes you may not go through graph. Just make sure you work it stage by stage, and you get your answer easily. Thank you for your patience and for informing me about this video. Thank you very much for bearing with us. Thank you for helping us to make this video known by people. You have been seeing positive results. Kindly share, subscribe if you haven't, and comment. Any question or area of clarification that is necessary, kindly contact us. We appreciate everything and your help to make sure that we are always present, always available on here. Thank you very much. We appreciate it.